Pringles are one of the most iconic and instantly recognizable snack foods in the entire world.
More than 100 million Pringles cans are sold in over 140 countries around the globe every single year.
Unlike conventional potato chips, Pringles are manufactured through a unique and highly engineered process.
Behind every perfectly uniform Pringle lies an extraordinary story of food science and industrial innovation. The journey from raw potato to perfectly stacked chip is one of the most fascinating processes in modern food manufacturing.
Pringles were invented by food chemist Frederick Bohr in the 1960s.
Frederick Bauer developed a uniformly shaped chip that could be stacked neatly inside a protective cylindrical can.
The saddle shape of a Pringle, known as a hyperbolic paraboloid, allows perfect stacking without breakage.
Pringles were launched nationally in the United States in 1975 after years of development. The name Pringles was selected from a Cincinnati telephone directory by a marketing employee.
Early Pringles faced regulatory challenges because they could not legally be called potato chips.
The product was officially labeled as potato crisps made from dried potatoes to resolve the dispute.
The cylindrical Pringles can was a revolutionary innovation in snack food packaging.
Frederick Bohr's ashes were buried in a Pringles can, honoring his groundbreaking invention.
In 2012, the Pringles brand was sold for approximately $2.7 billion. Traditional chips are sliced from whole potatoes, resulting in irregular shapes and sizes.
Pringles are made from a specially formulated dough created from dehydrated potato flakes.
The dough-based process allows extraordinary consistency in shape, size, and thickness.
The uniform shape is designed to allow chips to nest together perfectly. The ability to stack enables storage inside a protective cylindrical can.
The canister excludes air and moisture, extending shelf life significantly.
Controlled manufacturing ensures consistent flavor, texture, and salt distribution. Every single Pringle is virtually identical in appearance and structure. This remarkable consistency is achieved through precision engineering.
Unique shape, packaging, and quality have made Pringles one of the most successful snack brands in history.
The main ingredient in Pringles is dehydrated potato flakes.
Potato flakes are produced by cooking, mashing, and drying fresh potatoes. Using flakes allows precise control over raw material composition.
Wheat starch improves workability and final chip texture.
Corn flour contributes to the characteristic crunch of Pringles.
Rice flour helps refine texture and eating quality. Maltodextrin enhances dough processing and structure.
Vegetable oils are used in both dough formulation and frying.
Emulsifiers improve dough consistency and handling.
Salt is added both inside the dough and on the chip surface for flavor.
High-quality dehydrated flakes are the foundation of the entire process.
Potatoes are selected for high starch and low sugar content.
And easier for you to get
High solid potato varieties are preferred for flake production.
Potatoes are washed, peeled, and inspected by a Caucasian male worker before processing.
The peeled potatoes are cooked until fully softened and gelatinized.
The cooked slices are mashed into a smooth, uniform consistency.
Controlling cell rupture during mashing is critically important.
The mash is spread thinly onto large heated drum dryers. High heat instantly dries the mash into a thin potato sheet. The dried sheet is scraped off and broken into controlled flakes. Finished flakes contain less than 8% moisture. Each batch is tested for moisture, color, and viscosity.
Only flakes meeting strict standards proceed to production.
Tom. Flake quality directly influences the final chip's texture and taste.
The consistency on this latest batch is excellent, Mark.
The new sorting machinery is really paying off.
Yeah.
The purity is unmatched.
Agreed. This secures the order for Q3.
The manufacture of Pringles begins in the dough preparation area, where dry and wet ingredients are combined. Dehydrated potato flakes are stored in large silos or bulk containers before mixing. Computerized systems automatically weigh each dry ingredient with extreme precision.
Even small variations in ingredient amounts can affect the final chip quality.
All dry ingredients are blended thoroughly before liquids are introduced. Water is added in carefully controlled quantities to achieve exact moisture levels.
Too much water makes the dough sticky, while too little makes it crumbly.
Vegetable oils and emulsifiers are added to improve dough workability.
Heavy-duty industrial mixers combine the ingredients into a uniform dough.
Mixing time and speed are carefully controlled to achieve perfect consistency.
Overworking the dough can damage starch structure and affect texture.
The finished dough resembles firm modeling clay.
Dough temperature is monitored because it influences starch behavior.
Samples are tested for moisture content and consistency before proceeding.
Only dough meeting strict standards moves to the sheeting stage.
The prepared dough is transferred to the sheeting section of the factory. Counter-rotating rollers gradually reduce the dough to a thin sheet.
Roller pressure and gap settings are continuously monitored by automated systems.
The dough sheet is reduced to approximately 1.5 millimeters thick.
Achieving uniform thickness requires precise alignment and force. Specially textured rollers prevent sticking and add slight surface texture.
The dough emerges as a continuous flat ribbon on a conveyor belt.
A rotary cutter stamps out oval chip shapes at high speed.
Each chip blank is cut to an identical size and shape.
Scrap dough is collected and recycled back into the mixer.
Uniform blanks are essential for perfect stacking later.
Cut blanks move along conveyors toward the molding section.
Cutting speed is synchronized with downstream operations.
Misshapen or damaged blanks are removed before frying. The cutting stage is one of the most precise operations in the factory. Before frying, each flat blank must be molded into its signature saddle shape. The saddle shape is mathematically known as a hyperbolic paraboloid.
This shape allows chips to nest tightly without wasted space.
The curved design distributes stress evenly, reducing breakage. Blanks pass through specially shaped molds on a curved conveyor. The molds gently curve the dough in two perpendicular directions. The curvature is precisely controlled for perfect stacking.
Molding must occur while the dough is still soft and pliable.
Once fried, the chip permanently retains its saddle form.
The molding system is one of the key engineering triumphs of Pringles.
Shaped blanks enter a continuous frying system for cooking, overseen by a South Asian male food technician in his 50s.
The fryer maintains oil between 170 and 190 degrees Celsius.
Precise temperature control ensures uniform cooking.
Curved conveyor molds hold chips in shape during frying. The hot oil sets the starch structure within seconds.
Moisture rapidly turns to steam, creating crisp texture.
Frying typically lasts only 10 to 15 seconds.
Conveyor speed is synchronized to ensure perfect cooking time.
Chips transform from pale white to light golden yellow.
Automated sensors monitor color and remove imperfect chips instantly. Advanced optical sensors continuously detect chips that are too pale or too dark.
After frying, chips travel along a drainage conveyor to remove excess oil.
Automated vision systems inspect each chip for shape and surface defects.
The final fat content is carefully controlled between 25 and 30%.
Every finished chip must meet strict texture and color standards. Freshly fried chips move immediately to the seasoning application area. Seasoning is applied while chips are still hot for better adhesion.
The original variety is seasoned simply with perfectly balanced salt.
Pringles offers a wide range of flavors enjoyed around the world.
Each seasoning blend is precisely formulated for taste and aroma.
Seasoning powders are tested for flavor strength and particle size. Chips tumble inside large rotating drums during seasoning. The tumbling action ensures uniform seasoning coverage. Automated systems control the exact amount of seasoning applied.
Too little seasoning results in bland chips, while too much can overwhelm.
Cameras verify proper seasoning distribution on every chip.
Poorly seasoned or damaged chips are removed automatically.
Seasoned chips are cooled to near room temperature.
Cooling prevents condensation inside the can.
Seasoning consistency is monitored continuously.
The stacking process is one of the most remarkable operations in the factory. The saddle shape allows chips to nest naturally together. Identical geometry ensures perfect stacking alignment.
The stacking machine orients each chip before placement.
Conveyors gently separate chips one by one for stacking.
Guides and pushers assemble chips into neat vertical columns.
The brittle chips are handled carefully by an East Asian male researcher in his 50s to avoid breakage.
Each can typically contains between 80 and 100 chips.
Counting systems verify the exact number per stack.
Modern machines assemble thousands of stacks every hour.
The cylindrical canister is integral to the Pringles concept.
The can includes composite paper, foil layers, and a metal base.
Multiple material layers create strength and barrier protection.
A metal base is crimped onto the bottom for stability.
A foil seal provides an airtight barrier.
A plastic lid allows easy resealing after opening.
Can dimensions match the chip stack precisely.
Limited airspace extends freshness and crunch.
Cans are often produced at specialized facilities.
Finished cans are delivered to the factory for filling.
Stacked chip columns move to the can filling line. Empty cans are positioned upright on the conveyor.
We place the stacks gently into the trays. Preventing breakage is key to maintaining the set's value.
Nitrogen gas displaces oxygen before sealing.
Nitrogen prevents rancidity and extends shelf life.
The foil freshness seal is heat-sealed airtight.
The plastic lid is snapped securely into place.
Each filled can is automatically weighed for accuracy.
Underweight or overweight cans are removed from the line.
Every detail, from saddle-shaped chip to cylindrical can, reflects one of the most brilliantly engineered snack manufacturing systems in history.